Now that we know how to factor, we can also apply factoring to solving quadratic equations. I have a couple of definitions already pre-written out, so as you're going through and watching the videos, feel free to pause the video, of course, and write down these notes. So first, what is a quadratic equation? A quadratic equation is one that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Now, what does that mean? It's just an equation where your highest power is a 2. So we're talking about something that has a square in it. And that's the big thing here. So you have a power of 2. A, B, and C are real numbers, so they could be fractions or decimals, although I think most of our problems you'll see are integers, but they could be decimals and fractions as well. Here are a couple of examples of quadratics in different forms. So this one looks very much like the definition here, where you have a square plus an x term plus a number equals 0. That form here, where it's ax squared plus bx plus c equals 0, a, b, and c are just numbers. They're just holding the place for numbers there. That's called standard form. So we tend to use that form the most because it's nice and organized and clean, but your quadratic doesn't have to be written in that form all the time. So this one is also a quadratic. You can see your highest power there is 2. I could do a little bit of cleaning up, right? Combining like terms with that -10 and 16. This is also a quadratic because if you were to distribute this out, you would see that you would have a highest power of 2. You'd have an x squared term there. So this one's a little trickier because it's hidden. But all of these could be, or at least the last two anyway, because they're not already in the standard form, could be rearranged and cleaned up to be in the standard form. So we could, move terms around, we could distribute and multiply through parentheses and so on. But the big thing here is that you're looking at a power of 2. Now, there are different ways to solve quadratics, and we'll learn more of them as well. But for right now, the big one we're going to focus on is how to solve these by factoring. And there's something that we use to solve these by factoring, and it's called the zero factor property. Sometimes books will call it the zero factor principle, etc. It has kind of a few similar names. But the idea is that if two things are being multiplied and they equal 0, then one of those factors has to be 0, right? There's no way to multiply two things together to have an answer of 0 if one of them is not already 0 to begin with. That's what we're saying, right? Like I can't do 5 times 2 and make it 0. It just doesn't make sense. So that's what the zero factor property says. If something is being multiplied such that the answer is 0, then one of those original factors at least, or maybe both of them, have to be 0, right? But at least one of them has to be 0 to start. And we can use that idea to solve quadratic and even polynomial equations as well, as long as we can factor them. So I'm going to start with a couple basic examples. So these are already pre-factored for us, and the right side is equal to 0. So that is really important that you do have a side equal to 0 in order to solve by factoring. That is 100% needed or it doesn't work. So notice here that you have that equals 0 on the right side, and then your other side is already factored. So we've done a little bit of the work for you by pre-factoring. So once you have your factors, right, two things being multiplied together here, then what you do is you just set each of those factors equal to 0, like that, and then solve each set individually. So here you would add 3 to both sides. We get x equals 3. Here you would subtract 1 from both sides, and you have x equals -1, and we're done. Those are our two solutions. Now you can always check your solutions too by plugging these back into the original and making sure they work so that you didn't make a mistake. I'm just going to check the first one so you can see what happens. So when I plug in 3 here, I would get 3 minus 3 times 3 plus 1 equals 0. Well, 3 minus 3 is 0, and 3 plus 1 is 4, and of course 0 times 4 is 0, so it checks out. And if I plug in -1, I would end up with -4 times 0 equals 0, which also checks out. So you can still check your answers just like we always have, like with other kinds of equations, by plugging it back in and making sure it works. But that is our basic strategy for solving things that we can factor. Not everything is factorable, so there are some quadratics and polynomials that are not factorable, so we'll have other strategies for those later, but not right now. So right now, we're going to just use factoring. And here's just one more example, again, that's already pre-factored for us to practice with. Again, you can see the right side is equal to 0, which is key if you're using factoring as a strategy to solve. And then what I do is I set each factor equal to 0. So I have x equals 0, and there's nothing to solve there, so that is one solution. And then 5x minus 2 equals 0. I add 2 to both sides. I divide by 5, just using my regular solving techniques. And I see my other answer is 2/5. So I have two solutions here. It is very common to have two answers with quadratics. As a little tip, the highest power, so the highest degree on your polynomial will tell you up to how many different answers you can have. So sometimes we do get like repeat answers, or later on we'll see imaginary answers. So things that have imaginary numbers in them. But in general, that highest power for equations tells you about how many different answers you could potentially have. So if you have a power of 2, it is pretty common to have 2 different answers, although you don't have to. You could also have 1, or there could be a no solution there if it's not solvable. All right, so here's a problem that we're going to do from the start, where we actually have to factor it first. So again, notice that everything is equals 0 on one side, which is really important. So when we're dealing with quadratics like this, the first thing when you're solving via factoring is one side does have to be equal to 0. So that is your first basic step. And then the second thing you're going to do is you're going to have to factor the other side. Now, in this video, it assumes that you already know how to factor. So if you need to go back and review those techniques, then definitely go watch some of the previous videos. I have lots of videos on factoring that you can review, and I'm sure there's lots more out there as well. So it is assumed that you know how to factor at this point. And of course, there's more than one different strategy to factor a trinomial like this, so something with 3 parts. So as long as you have a strategy that works, then you're welcome to use it. For this one, I would probably use trial and error because it's a pretty simple one. I say simple because the first term is just x squared, so I don't have a lot of choice there. It has to be x times x. And then with 22, it could be 1 times 22, or it could be 2 times 11. Again, there's not many choices here. We just have to be careful because there is a negative here. So it's either -1 times 22 or 1 times -22, and -2 times 11 or 2 times -11. So there'll be a negative in there somewhere. And then if you're using trial and error like I am here, you're going to just have to try to find the right combination to get that -9 in the middle. And if you try some different options out, the one that works is +2 and -11. And again, it's actually really important here that you are confident in your factoring. So if you don't know how to factor, or you're still struggling and making mistakes there, I really encourage you to pause and just practice that a little bit more. Because if you can't factor, then all of your answers are going to be wrong for this section as well. So when you have your factors, pause and either mentally or physically write it out and multiply this out and make sure it does match the original so that you know you have the correct factors. Once you've done that, then you're going to set each factor equal to 0 and solve those two basically mini equations that you're creating. So I have x plus 2 equals 0 and x minus 11 equals 0. Here I can subtract 2 from both sides, and I have x equals -2 as my first answer. I can add 11 to both sides, and I have x equals 11 as my second answer. And then what you can do, you can go ahead and check your answers. Again, you don't really have to do that out by hand. You can check it mentally, but you could check it by hand. I'm just going to check the first one here just to show you how to do it. You go back to the original and plug in your answer. This becomes 4. Here I have a plus 18 minus 22, and that actually is in fact 0. If you add and subtract there, you do get 0, so this checks out. And I'll let you guys check out the 11 at home on your own and give that one a try. But they should both check out there, and now you know you do in fact have the correct solution. Okay. Let's do another one. Sorry, I wrote these out ahead of time. I should have left a little bit more room for myself here. There we go. All right, so same style here. The problem is though, I don't have an equals 0 on the right side. So before I begin, I'm going to bring that 49 to the other side. I'm going to add it to both sides. And when you do that, you do want to keep things in order. You do want your square term first, your x in the middle, and then your number at the end. It just makes your factoring much, much easier. It's not easy to factor if things are out of order. It's very confusing. So you do want to have everything in order as you bring it to one side. Now you can start factoring. I don't see an overall GCF here that I can factor out, so I'm just going to have to either use trial and error, or you can go ahead and use grouping strategy here. So whatever method works for you is perfectly fine with me. And the answer you should get is 2x minus 7, and then 2x minus 7. So you end up getting a perfect square here, so it's a repeat, right? But again, this is something that you need to make sure you know how to do. I'm skipping a lot of steps in the middle here because you should know how to factor. And you can either use trial and error, you can use factoring by grouping. Those are both great strategies for figuring out this answer here. But this combination does work and will give you the original. Once you have your factors, you're going to go ahead and set each factor equal to 0 and solve. So we're going to add 7 to both sides. 2x equals 7, divide by 2, and I have x equals 7/2. Now, if I solve the other one as well, you get the same exact answer, right? Because it's the same factors. So although you do technically have two answers here, we really only have one unique solution, right? Because it's a repeat. So our only unique answer is 7/2. Okay. Now I do want to point out that from here to here with the factoring, I'm looking over to my left because I have notes here. So I've already done this work out. It wasn't like I looked at this and said, oh, I know the factors like that. So please don't think that it just miraculously appears in my brain. No, I have my notes already done out before I did this video, so I knew how it would factor. So again, in between here, you're either doing trial and error or you're doing factoring by grouping to make sure that you have that correct factorization before you keep going. All right, let's do another one here. So again, I'm going to start. I do notice that the set is equal to 0, so that's great. I don't have to worry about that. And I'm going to start by factoring. I do see actually that each of these terms has a 2 in common, so I'm going to factor that out first. I also personally like to have my x squared term as a positive. So I'm actually going to factor out a -2, and again, that's my personal preference there. So if I factor out a -2, I end up with x squared. -4 divided by -2 is +2 with the x. And then 30 divided by -2 is -15. And then what I'll do is I'll break down this piece here and factor that. And again, you can use whatever style you like. X squared has to factor into x times x. I'm just using trial and error here. And then for the -15, I'm going to go ahead and use 5 and -3. That will give me that -15 and also that 2x in the middle. And then don't forget, this guy just comes down. So now I have everything factored. My right side is equal to 0. So I said each of my pieces equal to 0. So I have -2 equals 0, x plus 5 equals 0, and x minus 3 equals 0. Now, the first one here just doesn't make sense, right? -2 equals 0, not going to give me anything. So I don't need to worry about that one. And I'll focus on the other two. So here I'll subtract 5 from both sides. Here I'll add 3 to both sides. And I have my two solutions here of x equals -5 and +3. All right, I want to do one more in this video. And I'm just going to give it a little bit of a harder one here. It says solve x times 2x minus 7 is equal to 4. Now, I like to do an example like this because it's a little bit trickier. Because what happens is everybody looks at it and says, yes, it's pre-factored. I don't have to do that, right? The problem, though, is that the right side is a 4, not a 0. So if this was pre-factored and the right side was a 0, you're good to go. You can jump right in like we did with the first example or two in this video. However, if the right side is not a 0, you actually have to multiply it all back out and refactor it again, bringing that 4 to the other side. So I'm going to go ahead and start by multiplying through. I have 2x squared minus 7x equals 4. And then what I need to do is I need to bring the 4 to the other side. So I have 2x squared minus 7x minus 4 equals 0. And now I have that equals 0 on the right side. And now I will refactor. There is no shortcut here. It doesn't work that a number times another number. To get the result of 4, one of those numbers has to be 4. It doesn't work that way. It only works that way with 0. So we do need to go ahead and multiply back out, clean it back up, refactor, and try again. And when you factor this time, again, I would just use trial and error or grouping here. 2x squared, it has to be an x and a 2x. 4, you do have some choices there if you're doing trial and error. It could be 1 and 4 or 2 and 2. And let's see from my notes here, the one that's going to work is going to be a +1 and a -4. If you multiply that back out, that will give you that -7x in the middle. And then now I can go ahead and set each factor equal to 0. All right, I'm going to add 4 to both sides. Here I'll subtract 1 and divide by 2. So in this case, I have 2 solutions. I have x equals 4 and I have x equals -1/2. And again, how do you check those? Always go back to your original problem up here when you're checking to make sure you didn't make any mistakes along the way. And remember, we check by plugging it back in. So let me do the first one for us. We'll just do a quick check here. I'm going to do x equals 4. So I go back to the original, replace the x with 4. Okay. 2 times 4 is 8. So I get 8 minus 7. And 4 times 1 is 4. That does work out here. So that would be my final answer. Well, both of these would be my final answer. You guys can check -1/2 at home. But just a warning for this style here. If it's pre-factored, it only is helpful if it's equal to 0 already. Otherwise, it actually makes it worse. You have to start over and clean the whole thing up and try again. The last thing I do want to point out in this video too is that the order of your factors doesn't matter. So for instance, and this is true for, all the previous questions as well. So, if you wrote it like this as your factorization, so you have the same factors, it's just that you switch the spots that they were in. That's fine. Multiplication is commutative, and it doesn't affect the fact that you're still setting each factor equal to 0 to solve. So again, if you wrote your factors in a different order along the way, if you're trying at home and practicing, it's perfectly fine because you're still going to get those same 2 solutions in the end.